second part of the video on chapter 6.2. It's the last part. There are only 2 parts, don't worry. Let me add a little bit of vocabulary. I looked over the questions and big ideas, and I realized, you know what? I should probably add a little bit of this vocab here to make sure that you guys are okay with that. So the book is going to ask you in your exercises to write an expression in exponential form and then to write an expression in radical form. So let me make sure you guys know what that is. So this, of course, well, I think it's of course, this is called radical form. So when you write an expression with that square root symbol, the radical symbol, it's called radical form. And when you write the same exact expression with an exponent, it's called the exponential form. So if the question gave you the 4th root of 16 and wanted you to write that in exponential form, you would write it as 16 to the 1/4. If it gave you 16 to the 1/4 and wanted you to write that in radical form, you'd put the 4th root of 16. Okay? So those are some vocabulary words you'll need to know. There's another word I've mentioned several times, and I'll kind of write it out here. This number here under the square root is called a radicand. Very often students call it the number under the square root, but if you want to be fancy, you can call it the radicand. Let me go back to the first slide and just show you one more thing. Remember how I told you that roots and exponents were kind of like opposites? And then I did 8 squared equals 64, and then I took the square root of 64 and it equaled 8 again. Well, here's what I really did. I took 8 squared, and then I took the square root. Do you recognize that now? So what I'm saying is that 8 squared is 64, and then 60 to the 4 to the 1/2 equals 8. But I want you to notice also this. What happens if I use the power of a power rule? When you have the power of a power, what do you do with those powers? You multiply them, don't you? And what's 2 times 1/2? Well, 2 1/2s make 1. So really that's like saying 8 to the 1, which is 8. So you see how the exponent and the root cancel each other out in a sense? Because when you multiply them, you get 1. Kind of cool, huh? All right, move on. Here is what we're now doing. Take a look at it and take a deep breath and go, oh no! Yes, indeed. Now we're going to deal with what about 8 to the 2/3? In the last slide, we dealt with, well, what is 8 to the 1/3, to the 1/4, to the 1/2? Well, what if it was like 2/3 or 3/4 or something like that? Then it changes a little bit. But it's actually not bad. You can do this. There are 2 ways that you can do this, okay? So I'm going to break it apart. And you could think of it this way. 2/3 can be thought of as either 1/3 times 2 or as 2 times 1/3. So in other words, I want you to break up the 2/3. 2/3 is obviously 2 times 1/3. So I'm going to break it into 2 times 1/3 or 1/3 times 2. Now let's see which one of these is easier. On top, I get 8 to the 1/3, which of course is the cube root of 8 squared. The cube root of 8 is 2, and 2 squared gives you 4. So 8 to the 2/3 is 4. We could have flipped these 2 things around. Multiplication is commutative. It doesn't matter which order you do it in. In other words, remember 3 times 4 and 4 times 3 give you the same thing. So 1/3 times 2 or 2 times 1/3 is the same. But here, what do I get? I get 8 to the 2nd, which is 64. And then I have 64 to the 1/3, which is the cube root of 64. And what is the cube root of 64? What number times itself 3 times gives you 64? 4. Exactly. All right. So that one could have been done either way. So you can do it whichever way you like. It doesn't matter. You still get 4 either way. However, there's kind of a little piece of advice you might want to follow, because one way is easier than the other when you're dealing with larger numbers. Let's try this one, okay? So let's try 27 to the 1/3 to the 4th, because 4/3 is a third 4 times. So it's a third times 4. Or if I wanted to, I could go 27 to the 4th to the 1/3. It doesn't matter. You can swap them around. So the cube root of 27, that's easy. The cube root of 27 is 3, and 3 to the 4th is 81. No problem. What happens, though, if I do the 4th first? What's 27 to the 4th? That's 27 times 27 times 27 times 27. That's a big number. So that is why very often students like to take the root first or do the fractional exponent first and then the exponent because it allows them to have smaller numbers. You could do 27 to the fourth if you wanted to. In fact, I will right now. 27 to the fourth is, yeah, you're going to like this. It is 531,441 to the 1/3. And then now what I need to find is the cube root of 531,441. And of course, I'd have to use a calculator for that. The way I would do that is I would just do this number to the 1/3 power. And I mean, I know what it's going to be. It's going to be 81, but I'm cheating because I got it in the first one. So here's my advice. Keep the numbers small and do the fractional exponent first to make it small, and then do the whole number exponent. All right. So I want you to try it now. Pause the video and try number, no, there's no number there. So try 16 to the 3/4. Here's what you should have done. I would have done this. So 3/4 is 3 times a fourth. So I'm going to do 16 to the 1/4 cubed. So it's the fourth root of 16 cubed. That's 2 cubed, which is 8. You get it? Cool. What about 16 to 3/2? Notice that 3/2 is more than 1. So this number should be bigger than 16 because 3/2 is a number more than 1. 3/4 is less than 1. So it's going to go down. 3/2 is more than 1. So it's going to go up. Try it. You should have done this. You should have said that's 16 to the 1/2 3 times. That, of course, is the square root of 16 cubed. That is 4 cubed. And that is going to be 64. All right, for a fun little challenge, I'm wondering if you can figure out 32 to the negative 3/5 by yourself. Why don't you try it? No, too hard? Well, okay, here's what you should have. I have a negative exponent. What do I do with negative exponents? I put them on the bottom. So what I end up with is 1 over 32 to the 3/5. That's all, just that. So then I'm going to get 1 over 32 to the 1/5 cubed. That would be the 5th root of 32 cubed. The 5th root of 32 is 2 cubed, and therefore your answer is 1/8. That's how you deal with that one. It's not really a big deal. Just if you have a negative exponent, put the base down on the bottom, the reciprocal 1 over 32, and then go ahead and treat it normally. Okay, I would like for you guys to take a little quiz. Yeah, no, it doesn't count. It's just to see if you got it. Okay, so try those 3 and see if you can do it. Okay, I hope you press pause. I hope you tried it yourself. Here's what you should have done. If you're doing it right, you should have had 216 to the 1/3 squared. That's the cube root of 216 squared. That's 6 squared, therefore 36. You get it? Awesome. High five. Next one, 16 to the 1/4 to the 5th. That is the 4th root of 16 to the 5th. That is 2 to the 5th, which is 32. Notice that 5/4 is more than 1, so it's going to become a bigger number. And 2/3 is less than 1, so 2/16 is going to become a smaller number, as it did. All right, negative 2/3. Ooh, this one's a hard one. All right, first of all, I know that 2/3 is less than 1, so this 27, the answer is going to be less than the 27. My number will be less than 27. So let's see. First things first, I'm going to put this down on the bottom and make it a positive exponent. Then I'm going to do 27 to the 1/3 squared. That is the cube root of 27 squared. That is 3 squared. That is 1/9. Did you get that one? Awesome possum. Okay, on to big ideas you go. And we're going to have a little quiz on this, and you make sure that you show your work this way, okay? It's got to be done that way. I will see you guys later, and thank you for paying attention, and thank you for taking notes. Goodbye.